Yeah, there we are. So, hello everyone. I think I've met some of you, but not all. It's the first time I'm joining the symposium actually. My name is Yorick Liefting, and I'm based at Wageningen University in the Netherlands, where I work in the same group as Patrick Jensen. I think you've all met him on previous occasions. And thanks to Graham for introducing this topic, because with these three IT tools that we have within the ENETWILD project, I think we have a nice complementary set, and there's really different target audiences there. So I want to share some information about Agouti, which is not just developed for ENETWILD, but was already there, established before the project. But together with you, I think we've made a really nice case and improved the platform quite a lot. So we've heard plenty about it, but there's a few central questions in wildlife monitoring, such as where do animals occur? Sometimes we don't know. What abundance, densities, etc. What are the trends? So are populations going up, down? Are they stable? That's all very relevant information. And also we've learned, for example, for the African swine fever and avian influenza, that we need to know if there's interactions between species. Now, there's a whole bunch of more questions, but camera traps, they pop up every now and then because they are kind of a central tool. So you can use them for many of these questions. Now, there's this problem. Basically, if you go through the published literature, you will find some data, which then may prove very difficult to actually get access to. But there's plenty of more out there. So there's lots of people that have done work, but they've not published yet. So these data are sitting around somewhere, but no one knows about it except the person that collected it. There's also citizens that do lots of work. So you can reach those probably through apps like iMammalia or Mammal Web and try to convince them to share what they have. But even then there's more because there's cherry-picked data. So people have collected data and shared some records, for example, for one or two species of interest, and the rest they've deleted because I don't care about wild boar. It's so common, I'm not going to save those records. There's also data without evidence. So you've claimed that you've seen something somewhere, but there's no evidence to actually prove it, which could be crucial if that is an invasive species, for example. And then, of course, we have deleted data that is simply mistakes or, oh, it's taking up a lot of space on the server, so let's get rid of it. Project complete. So yeah, there's also lots of potential there. But with Agouti, what we are trying to do basically is to provide solutions for people working with this type of data, mostly with camera traps. So we started out just for ourselves with a student project, and we thought, yeah, well, I mean, Excel is not a database, right? So it's a spreadsheet tool. So we need something better than that. And we just started to think about yeah, some sort of application where you could link your evidence, the photographs or the videos, together with your observations. So make data and also voucher data. It's kind of an analogy to museum collections where you have the actual specimen sitting somewhere. Now, what we basically want to achieve there is that image processing becomes more efficient. I mean, looking at a picture, writing down what you see in the picture, and then repeating that, that doesn't scale. You cannot do that for 10 million pictures. So we need some nice processing tools for that. And also what we need is a long-term storage of images and data. I mean, these hard drives that people have sitting in their drawers, at some point they disappear or they simply don't work anymore. And then the data is gone, which is a shame. I mean, imagine if we had kept all the data that was collected over the last 100 years. That would be a very wealthy set of information, but we're not there yet. And then, of course, once you have data, you need to start thinking about exchanging it. So publish it somewhere, make sure that, as Graham mentioned, that there's a proper license so people know what conditions they can use this data for what purpose. And then specifically for this project, we had the opportunity, thanks to the funding also from EFSA, through ENETWILD, to really add these density estimation tools, so the random encounter model, developed also by Marcus Rowcliffe, who's in the audience today. And so we could implement that in the app. So also hoping that that will help us to get to these numbers that we need for all these policies and all the stuff we've talked about before, to get them more quickly. So just briefly about Agouti itself, it's an initiative that was started by Wageningen University and INBO together as partners in this project because we had an overlap in needs and we thought like, hey, we can do this separately, but it's much better if we do it together because then we can share resources. Hopefully it will be more efficient. And what it basically tries to do is to offer some tools where you can organize your project. So not just information about the project, but also I mean, where are your sampling locations, your probably need to give people access to your project, and they need to have different roles. So you have someone that maybe does only field work, and others that really need to have an overview to see how the overall progress is going. But you want to control that. So not everyone needs to be able to access everything, for example. Now, it allows you to import images and video data, although video data does have some drawbacks, but people have used it. What we do is there we try to group these images always in events. So if you have a trigger of one of these camera traps, many of you have found out that it will take multiple pictures to increase the chances that you can see what's going on. But that doesn't mean that you have multiple observations. It's one observation that is just spread across multiple frames. And more recently, we have started to work with AI, and in this case, I don't mean avian influenza, but artificial intelligence, to assist, us as camera trappers to process this data, because doing it by hand is tedious, and probably the computer can help us there. That's the hope. And also very important, that's what we noticed when discussing also with our users, is that especially here in Europe, also other parts of the world, they find it important that the data that we have remains physically in the EU. So if you look at the small print of many commercial cloud services, basically your data is gone. But I won't sit and not saying that they actually use it, but if you upload a picture to Google Drive, probably you've given away a license to Google by doing so. So until we know how to properly handle that, we just said, okay, we just keep it at where we can control it. So that's in Wageningen at the own data center of the university. So that's a direct line for us. And to get the data out of Agouti, we started working on this data standard. It's called Camera Trap Data Package, which was spearheaded basically by people from INBO, Peter Desmet, and others, and also together with the camera trapping community. So Agouti is not the only thing out there. What we try to do is kind of have a common data standard that will allow people to exchange this data and then knowing exactly what they will get. So not 20 different types of Excel sheet, but always the same format, and you load it into your scripts, and you can very easily then start doing the more broadly scoped studies. Now, a little bit about this artificial intelligence. Also within this project, we focused heavily on European species. What you see here is a so-called confusion matrix with on the x-axis the species, or it could be a genus or a higher level in the taxonomy. And at the moment, we have 67 mammal and bird species in there for Europe. And what you want basically is that the x-axis and the y-axis, that's prediction from the computer. So you give it an image and you ask what's on there, and then you know the truth and you see if those two match. And in an ideal situation, you get 100% match. So the diagonal that you see here is completely dark, and there's no, let's say, pixels around that with any color, because that would mean there's a mistake, so a misclassification. So I cannot put any number on this specifically. I mean, you can do the calculations if you like, but I mean, what we're seeing here is that actually it's starting to work, right? Because the darker this diagonal, the more predictions are actually correct. So this is an indication that we are well slowly developing something that may be useful in the end. Suscropa, yeah. Yeah, so, I mean, developing the AI is difficult, but our position with Agouti is that it should facilitate users. So what we do not want is to turn things around and have this AI become a goal in itself. I mean, there's people working on that, and that's all very well, but in the end, we need it to work for us and not the other way around. Now, to give you just an overview of Agouti as a platform, so that is what's in there. Well, we have about 8,000 users, and these are mostly professionals or organizations. So really scientists, NGOs, conservation agencies. Sometimes it's groups of hobbyists or foundations that are more local in scope, but we're not targeting the individual camera trapper. We're really looking at people that do this in sort of systematic survey. And we saw in previous presentations different types and strategies, but all that stuff we try to cover with Agouti. It's also why we started it in the first place. And what we do is we focus on Europe, hence also name agouti.eu. But it's available for everyone that likes to use it, because we want to make sure that if you think it's useful, then please join. So the total scope in there is we have quite a lot of data. So about 105 million images at the moment. I just checked it last week, which is consisting of about 5.5 million observations. So what you see there is that a lot of data is not processed yet. So people are apparently not able to keep up with the amount of data they're generating. So that's also why we need this AI. Now, if you look at ENETWILD, I just pulled out these numbers, and there may be some discrepancies there, but just to show that we have actually quite a nice data set appearing as kind of these pilot studies were done last summer and fall. And there, yeah, when we're looking already at about 134,000 observations of wildlife. So that those are a real number. And so on the map also before that these are spread over all of Europe. So I mean, perhaps this may actually work. Now, what we've also done is develop these density estimation tools. So basically implementation of the random encounter model. And just for sake of being complete, I want to show you basically the process, because we have made a first implementation, but still it's quite tricky. And I think it's important that everyone knows what these requirements are. So the first one is basically a camera calibration, and camera calibration has to be done for each camera model and resolution setting. So different image size you get out of the camera, you need also to do the calibration. But those are then available in Agouti globally and also for everyone else available. So it's a one-time thing. The second thing you have to do is for each deployment, have a calibration where you're fitting this model for that specific deployment, because of maybe some terrain going on, some differences, so it also needs to be done. And then finally, you have to track the animals in the actual sequences. So this this picture here is for the camera calibration. And you can see the top-down view in the right that it's on different positions. And there you also need to know how far this is from the camera. So if you want to know the intricate details of that, then please, I refer to Marcus. But what is important is that this is now available for you to use. So you don't need to know all the details about REM to still use this for your project. And that is an important step if we want to come to, let's say, more like a pipeline where you collect this data in a certain way, you do this calibration, you mark the sticks, and then finally you track the animal. So here there's a road here, and every frame you then, in this case, I think front left foot is marked in each frame. And from that, we can then get the numbers out that you need to do the actual density estimation. So yeah, that's an important output of this project. Now, of course, we're not just idle. We're also working on new features, and the most important ones, also coming from feedback that we got from all of you, is that we are implementing our real-time AI. So basically, you can manually go through your images, but then click on a button, and it will produce some suggestions, and then say, that's good, that one is correct, and you select it, and immediately you're done. That means that you don't have to go back and forth between all the AI stuff and the already validated observations. We also want to improve the AI. So there's certain groups of species, for example, some of the deer species or the corvids or songbirds that are easily confused because they're so similar. But we do have the indication that the AI may be able to tangle them apart if we do a multi-step process. So first you go to a generic level. So let's say it's a cervid. And then with a separate model, you try to classify it further down to the species or even subspecies level. And also, I mean, not expecting that we're the only one or the best ones in AI, definitely not. But there's lots of other initiatives, like, for example, French colleagues made a really nice model called Deep Fawn. And I mean, we have made it available in Agouti in collaboration with them, because I mean, it's better if you choose, right? So use what works for your project. It's not one size fits all. And also the mega detector developed by Microsoft is a more generic one that can only identify if there's an animal in the image or if it's blank. So if there's no specific model, you can already use something. So basically use whatever you like. And then finally, the user phase will be improved. That's about 80% completed now. I'm not going to show you a live demo because it will be a little bit tricky. But basically, we try to just improve the interface also based on your feedback. So to have a little bit more personalized view. So you have a list of tasks, so you can see, I mean, these deployments have been assigned to me to process. I can mark a few favorite projects. So it's not so complicated stuff, but I think it will make the user experience much better. and therefore also make it more attractive for people to use. And then hopefully they will start using something like Agouti, and then eventually share their data. Also, we have worked on explore functionality, where basically if you choose to make your profile project public, which is not the default, everything by default is private because we leave the control with the project owners. You can now show this on the website, so people also know who to contact if they want to get in touch or collaborate or etc. So there also, it's like a small thing, but we hope to facilitate contact between researchers and, I mean, being aware that they are working on something that may be similar. Also, there will be some additional features, so some more customization. So you can choose, I mean, what type of information you see in the system, filtering, sorting functionality. All of that will make it just more user friendly. And here also the annotation view. So this will implement the real-time AI. We'll have a new thumbnail view. And here on the right-hand side, you see this observation list, and then the analyzing sequence. So that will be a button like that. And this is actually the actual design we came up with. You click the button, it will produce a list of observations. And if the right one is in there, you select it. And otherwise, you simply ignore it and do it manually anyway. And we're continuously using all of that information to improve the AI so it becomes more accurate. Now, another important step is the ChemTrap DP format. So now we're still stuck at version 0.6 or something like that, but we're very, very close to version 1.0. And that will be a huge milestone because from that moment, we can also change the export format of Agouti and a Trapper developed at the Mammal Research Institute in Poland. And then all the users will use the same output format. So whatever app you use, then you get this type of data out. And that has all the information that you need to answer most of the questions that we're concerned with. And also good to know that we're in discussion, and I say we is mostly Peter de Smet again, with GBIF to adopt ChemTrap DP as a standard, as a data standard. So you don't have to go through the conversion to Darwin Core, for example, to get this data out in GBIF. So that's nice because that will offer up some opportunities to publish, for example, your data directly from your Agouti project to GBIF, and then everything's there for people to. So yeah, just in summary, we hope that we have let's say a complete solution for managing your camera trap projects to processing data and then all the way to publishing. What is essential is that we think that if you run a project, you're the one in charge. It's not us. So it's not Agouti that will be owner of your project. It's you, and you decide what to share, when to share, if to share. That's also a discussion point. So if we want to convince people to share the data, maybe there should be an incentive somewhere, or maybe we should have something in our conditions and terms to encourage data sharing. And yeah, some other topics that we could discuss. This is not just Agouti, but more in a broad sense, I would say, is maybe we need to have a sort of validation workflow. So now most data is just there and someone looks at it and then it's done. But you may actually want to have an expert checking it, especially if it's a certain species, for example. We could discuss what this workflow of publishing your project, your data to GBIF should look like. So should it just be a one-click process, or should it be a manual thing where you still have full control of the transfer? And also, how can we improve the AI? So we talk about species level recognition and doing that automatically. But we're also doing these trials with individual recognition where you can compare spot patterns. You can look at the count, for example, how many animals do you have in the sequence? It's something that AI can help with, age classes, sex classes, behavior even. And there's probably plenty of stuff to think about. So, but I mean, you need to tell us what we should focus on, and then we can figure out what direction to head into. So that's what I want to share with you. Thanks for listening. And